let's hope that's why. Let's see, screen. Okay. So tonight we are doing 11.1, hopefully. All right, and let me just get the chat up. So good evening, everyone. Is this what yours looks like? Hopefully.
Yeah. I was looking at that animation video. It's like 8 seconds.
Yeah, and I pulled up that link, so I'm hoping, or maybe, I don't know, there might be multiple links, but we'll figure it out. Hopefully it works. Hopefully I pulled up the right link. I'm not really sure. Okay. So tonight we're going to talk about ellipses, and some other kind of properties or things that have to do with that. So now I have to make sure. Okay. Before, can you explain the plane curve with theta? I don't know what you're referring to, the plane curve with theta. Should I go to the notes from last class?
Do you remember last time we said there is a question, the whole circle is continuing, but there was a
like the circle, and it was only half of it?
Yes, because you have restriction, right?
Well, yeah. So that was just because like if you're from 0 to pi, or negative pi over 2 to pi over 2, or whatever it is, you're not on the whole circle. So whatever the angle.
It was like same question type, like the plane curve question C, I guess. X equal -3 cosine t. Instead of t, there is a theta. So it is in the.
Oh, t and theta are. Oh, I see. There was another theta, you're saying, or another parameter.
Instead of t, there is a theta over there. So in the Alex question 6.
Like that?
In Alex question 6, probably.
Oh, question 6.
Not in the.
I see. This is only for projectile motion. And can you see? You can see my screen, right?
No, not this one.
Oh, not this one?
Just a second.
Okay.
The question is question 6 in Alex.
Oh, on the homework. Sorry. Okay. I can't pull that up on my iPad because it'll make me. It'll be really hard. Because
I'll just tell you the question.
Yeah. Okay.
X equals 7 cosine theta and y equal -7 sine theta. And it just said eliminate the perimeter and write an equation in rectangular coordinates.
Yeah, so this is similar to
question C, probably.
I think where was eliminate? There was a question that had us do exactly this, so I'm wondering if we can.
This one, you passed the C.
Oh, this one.
Yes, just
okay.
Just like this.
So the fact that there's t here and theta there, it doesn't matter. They're the same thing. So t in this case is theta. It's the same. It's just using a different formula. So for this problem that you just explained, you're going to do the same thing where you use sine squared theta plus cosine squared theta equals 1. And you'll replace sine theta with, so sine theta equals y over -7, right? And you'll replace cosine theta with x over 7. And then you'll just solve, you'll get a circle. You'll multiply both sides. You'll square it. You'll multiply both sides by 49. And then you'll get an equation for a circle. Does that make sense?
Yes.
Yeah. So theta and t in this case, like I don't know. I mean, I feel like I've said it before, but sometimes you have both. Like in this project, I thought that's what you were talking about, where we have both. In which case the t is representing time and theta is the angle. But then sometimes, for whatever reason, we use t to represent an angle, even though we usually use theta. So math is confusing. No, I'm just kidding. So that hopefully that makes more sense now, maybe.
Mm. Yeah.
And I would say for that particular problem, if you're having trouble too, make sure you view like the similar example, right? Maybe it'll do something that helps
Yeah,
you
yeah.
understand.
It's not always helpful.
Oh, it isn't? Okay. Okay. But yeah, I mean, hopefully that made a little bit of sense.
Yeah.
Um,
Thank you.
yeah. Okay. All right. Give me 1 sec, guys.
There was also another one. I don't know. I'll let you finish your thing. But,
No, go for it.
well, it was like a half of a circle, and I think it was a half circle. And you looked at the graph, and it says, determine the orientation, and there wasn't any. There was like it wouldn't go either. There was no orientation.
Oh, weird.
You
and
know,
is that the answer? The answer was none, or you don't?
yeah, none. Because
okay, so they're just messing with you then, because that's weird that they would like on a test or something. I would never ask a question if there was no orientation given, right?
Yeah, it was really confusing. I was like, but it was like, it was so weird.
Yeah, that is strange.
Yeah. I don't know if anybody else saw that. I can't remember which one I'm looking
You'll
at.
have to I expect Joseph to chat about it in your group text, in your group share, whatever what is that called? I don't know.
Group me.
There you go. Thank you. Yeah, thanks, Joseph. See, I expect that to be a chat now about the no orientation problem.
It's a strange one.
Okay. All right. So we can get back to it. So sorry, guys. Okay. So again, today, well, we're talking about different shapes, different things, but we're starting with this ellipse. And basically the way that like, how does an ellipse come about? Well, or how do any of these things come about? I mean, this is one way, but through conic sections. So if you take cones, and these are, well, the way I think of these ones they're like, they're two cones on top of each other, right? But they're maybe like a tube twisted together and then two cones are formed or something like that, right? So you pinch it in the middle. But they really only needed to show one, but I guess because it's cool and in 3D, they can show two. But I couldn't draw it for the life of me, right? So if we wanted like a circle, well, if you literally took a cone and you cut across where this brown kind of plane is, that the edges of the cone creates a circle. If you cut it at an angle, so this is like angled cut, it creates an ellipse. If you cut it vertically, it creates a hyperbola. So like it's this side and this side. And if you think of this as like the XY plane or something, like that's when you graph it, that's kind of what's happening there. And then a parabola is if you cut it at an angle such that you cut it at an angle where you're not in the top half, right? You're only in the bottom half, and you're not you can't connect all the way through like you can with the ellipse or the circle, right? So that's when a parabola happens. And you can just see those with the pictures there. Now we're going to today, you know a lot about parabolas, maybe a little about hyperbolas, and a little about circles. I was able to post those circle notes. So please take some time to review it if you need it. If you don't, and you're like, yeah, I'm just going to go with the flow, that's fine. But I did write those notes out and it's only 2 pages and I posted it Tuesday. I kept calling today Tuesday. So, that is how today is. But I did post that on Tuesday. And so today we're going to talk about a lot like things to do with ellipses, like graphing. Okay. Now, the first thing is if we graph it centered at the origin. So this is not always true, but we're just going to take a look. And here's our definition. So an ellipse is the set of all points X and Y in a plane. You can think of it like this, up here, right? Such that the sum of the distances between X and Y and two fixed points, or the sum of the distances between x, y, that's 1 point, and two fixed points on the ellipse is constant. So what this means is that if I took that circle, and maybe I can draw it, let's see. If I took, a point x, y here, but then I took 2 points, and maybe that's I took a point here, and then on the plane, like think of that as the plane. If I took two other points, this distance that's created from the fixed point to a point all around, it should be constant. Now we call the fixed points foci. It's just focus points, and the other point is just a point. I guess XY is just a point on the ellipse. Okay. And then you can see here, you can see in this picture, so they've labeled some things, right? The vertex or vertices is plural, focus, foci is plural, major axis, minor axis. So it depends on where you're going for major and minor axis, but I'll show you. This is basically one of each, right? So I'll show you. So let's maybe start with vertex. So vertex, vertices, that's going to be the points at the end. So each of these, like this is a vertex, and let's say it's at like a comma 0. This is a vertex. Let's say it's at negative a comma 0. And then on the other one, same thing. Like these would be, the vertex is basically the points on either end where your focus points are of the major axis, which is like going to be the longer side. So vertex. So this would be like, except this would be 0, negative a, and vertex, a comma 0, right? Now, if we want to talk about focus and foci, so the focus, they're labeled here. It's these 2 points and these 2 points, right? And those are the focus points. Now, let's call them, say, like this would be C0, negative C0. Basically, we're taking 2 points that are equidistant away from the center. So this one might be 0, C, and negative C. 0, negative C. Okay. Then we have the major axis and the the minor axis. So again, the major and minor, it's based on how long the X or Y axis is inside this ellipse. So this here is going to be the minor axis, and this shorter one here, also the minor, right? Because it's the shorter axis, and maybe these points are like negative B0, B0, maybe this, I don't know if we'll use this later. That's why I want to maybe label 0B, 0, negative B. And then our major axes or axis is this right here, right? The longer, the major axis and the longer here. And this is just terminology. Like, we haven't really done anything. We're just seeing, what does it look like? What does this mean? And notice that the foci are always taken on the major axis. So if you notice they're not, then, this isn't going to be correct. And what the definition above is saying is that if we call like this distance D1 and the longer distance here D2, this is D1, and this is D2. So D1 and D2 are constant. Or D1 plus 2, sorry. It says the sum between two distances. Sorry. It should be plus. D1 plus D2 is constant. So if these ellipses were the same and you took any two focus points and drew a line to another point, if you add the distance of those lines, it's constant and it's the same everywhere. Now this animation, I was going to attempt to share it. So let me see if I can. Except I have to stop on this one. So just give me a moment. And I'm going to share this one. Let's see. Do we see this? Hopefully, yeah. So this is, if you click on that link, which you guys can, or if you type it in your chat or whatever. Oh, maybe actually I'll send it in the chat because I think. Oh wait, this is not the right link. What happened? This is a graph of the ellipse. What? Okay, this is weird because I copied and pasted that link and this is what came up. It was like an ellipse, which.
I think that's on page 3, maybe.
Oh, so maybe this is the wrong. Oh no, maybe I pasted it over. All right, give me a sec. Let's open this up real quick. Notes, unit 4. All right, let's go to it and watch the little, because the video is cool. I must have pasted it right on top of the same tab and not closed it out. Okay, so let's go. Where are we at? We are at here. Let's go here. All right, let's see what happens. Is it going to go? Yeah, all right. I don't know if the sound will work, but we could at least play with it here for a minute. Oh. All right. We're really testing the internet tonight, aren't
I
we?
don't think there is any sound. But,
Yeah, okay. I didn't know if there was. But okay, so here it is. So what's happening is these are two foci points or focus points. And as this point goes around the ellipse, the distance, the sum of them is exactly the same. It's constant. Okay. So they went like really fast, right? But like, so they're showing you here's this part. But then if I move the point over here, these lines are different lengths, but their sum is the same. That's what that's trying to say. It's way easier to see in a picture than via words, right? I was even confused for a second with words, right? And later, we're going to look at this, which maybe I won't pull it back up, but maybe I'll write it out or something. We'll figure it out. But you can look how cool this is in Desmos. You can graph like general ellipse and say what HK and then like plug in these values. So that's pretty cool. So we'll take a look at this.
That's cool.
Okay. Now I have to figure out how to get back to Zoom here. Share. Let's go. Oh yeah. Okay. Okay. Sweet. So we're back in action. And that was pretty cool. Yeah. I'm glad I found the notes rather quickly, or at least seemed like it was quick. Okay. So now that we've kind of understood maybe what it is, an ellipse looks like a circle. It's just like a squished circle. It's an oblong. Is that the word? Oblong circle? I don't know. So we have some formulas, just like a circle. We have some formulas that we can tell if it's an ellipse, or a circle. So we're always assuming that A is greater than B, which is greater than 0. So these numbers are always positive, and A is always bigger than B. Okay. And then we have this x-axis is our major axis, right? And we're saying the y-axis is is the major axis here. So there's two situations, right? If x, so notice how above, in this case, in this one, x was the major axis. And this one, y was the major axis, right? So there's different formulas based on what the major axis is, right? Because that makes sense. And so if x is the major axis, then we have, this looks a lot like x squared plus y squared plus 1 is a circle. Elongated, thank you, not oblong. I swear there's something called oblong, but maybe I'm just maybe I'm losing my mind. But yes. So x squared plus y squared equals 1 is a circle. But if we divide by numbers here, then it becomes, this is the equation of an ellipse, okay? If we were to graph something like this. Now, this is what happens, and A and B are related to this up here. So A is like our vertex. So if we're looking at the x-axis being major, A and negative A, those are our vertex points. And B and negative B give us our minor axis endpoints. So we can graph this. We don't have focus points, but because you pick that yourself. But we can graph this based on this equation. And so the foci, c squared would be a squared minus b squared. And then if we have the y-axis is major, again, I have x squared plus y squared equals 1, and I'm dividing by b squared first. So I divide by b squared in the x term and a squared in the y term. And notice up here, I'll then get this should be 0a, right? Oh, good thing I came back up to this. This should be 0a. Right? So 0a and 0 negative a, that's our major axes endpoints. And then our minor ones are b0 and negative b0. And so they're flipped here. Like, notice, they're just flipped because, like, if x is the major axis, a goes with x and b goes with y, and vice versa. If y is the major axis, b goes with x and a goes with y. And you can still compute the foci points from this, right? Okay. Now, they give us an example, and it's nice when they're perfect squares, but that won't always be the case, right? But in this case, it's nice, at least for our A and B here. So we can see here, like this, if you wanted to rewrite it, it's like x squared over 5 squared plus y squared over 4 squared. And how do I know which one the major axis is going to be? Well, remember back at the top, A is bigger than B is bigger than 0. So this has to be A, and this has to be B, because A is bigger than B, right? So this tells us that the x-axis is major axis. And A equals 5 and B equals 4. Right? So our vertices, the endpoints here, all right, if I want to graph this, 1, 2, 3, 4.
B is equal to 2.
Oh my God. Yeah, what? Wow. Okay. B is 2, not 4 squared. Well, okay, it's still smaller, I guess. So at least I had that. But yeah, this should be 2, right? Okay. And so I can plot 5, 0 and negative 5, 0. And I know that's going to be on my major axis. And then I can also plot 0, 2 and 0, negative 2. And I can actually connect these already, right? Okay, there's the graph. And I do want to identify the foci and the vertices. So we've got the vertices. So vertices were 5, 0, and negative 5, 0, right? But now I want to get the foci. So the foci are, remember, c squared equals a squared minus b squared. So is that 9? Oh no, it's 21. Oh my God, 21. Okay, so this isn't so nice because c is plus or minus the square root of 21. So this is one of those examples where it's not going to be perfect, but that's fine. What is the square root of 21? Well, it's between 4 and 5, right? Because 4 squared is 16, 5 squared is 25. So it's between there, maybe slightly closer to 5, but you could get the decimal, but I would keep it, yeah, like 4.6. Okay, that's what I thought. But I would keep it as a rational number for your answer. So like you could write foci points are square root 21, 0, because they're going to be on the x-axis, right? And negative square root 21, 0. And we know they're like 4.6. So okay, if you wanted to plot them, 1, 2, 3. Like, okay, they're way too close to 5, but here they are. So focus point, focus point. And if you wanted to label vertex, right? I guess you don't need to label the other points that are on the y-axis, but yeah, but there's our ellipse, okay? Not so bad. Now, part B requires a little bit more work because I see something here that I'm like, okay, this might be good, but I don't want coefficients in front of my x and y. So I don't want coefficients in front of x and y, and I want 1 on the right-hand side. It must be 1, right? So I was going to say I could divide by 49, then divide by 9, but lucky for us, 441. This actually equals 49 times 9. But we're going to divide everything by 441. Right? So I would get, 49 over 441 is actually 1 over 9. Okay, so I get x squared over 9. So 49, I'll write this off to the side. And then 9 over 441 is 1 over 49. So typically they will give you something nice, right? So that, now we have x squared plus y, x squared over 9 plus y squared over 49 and equals 1. Okay, so now this is my equation of the ellipse. And what does this tell me? Well, 49 is bigger than 9. Therefore, the y-axis is the major axis. Right? And A equals square root of 49, which is 7, and B equals 3. We don't really care so much about B, but we like to get that too. So now I can graph 0, 7, 1, 2, 3. So this is 0, 7, and then 0, negative 7. And remember, these are all ellipses centered at the origin. There is such a thing as not being centered at the origin, and we'll get there, but we're starting with centered at the origin, which is just nice, right? But think about it. You could shift any ellipse, just take it and shift it, and the center is no longer the origin, like that, and that's perfectly fine. And we'll see how that happens. And then I want 3, 0, and negative 3, 0. Okay, so I could connect this, but I think I guess I'll connect. Right. And then we just have to get the foci. Okay. Ooh, that wasn't super, but that's okay. So here and here are the vertices, right? Vertex, vertex. And then we want to get the foci. So let's do this. So to get the foci, we're going to do c squared equals a squared minus b squared. So it's going to be 49 minus 9, so it's 40. So c is plus or minus the square root of 40, right? Um, okay. That means that, okay, well, square root of 40, again, it's going to be between 6 and 7, maybe a little bit closer to 6. So like maybe 6.3 or 6.4, something like that. So 1, 2, 3, 4, 5, 6. So again, it's like really close here and really close here. But okay, my graph is not, it's so tiny, so it's not super accurate. But this is 0 comma square root of 40. And this one is 0 negative square root of 40, right? And we have the foci are at those points. And then the vertices are these points here, right? Vertices. Now you could simplify. Okay, I should have maybe done this, and maybe some of you already saw it or you already did. 40, you could simplify this to be like, this is like square root of 4 times 10, which is 2 root 10, right? So you could have done plus or minus 2 root 10. And then that's a little bit nicer if like, then, I mean, I don't know how your homework might be picky. So like 2 root 10 might just be a nicer answer in negative 2 root 10 than just square root of 40. However, they're the same thing, right? So I want to point that out because possibly in your homework, you're going to have to do this, have to like simplify or simplify. That's what it's called. Okay, so those are ellipses centered at the origin. Now we get to the fun stuff when they're not centered at the origin, right? And good old handy dandy vertex or center here. So this is why also the circle notes were kind of important, I'm realizing. Because if you don't remember anything about circles, like this, it's so related to circles that it's just good to review, right? So maybe next time I'll stick to the curriculum, I guess. But x minus h squared plus y minus k squared equals 1. That is like x squared plus y squared equals 1 is the unit circle. And if we shift it to be centered somewhere else, it's that what I just highlighted, x minus h squared plus y minus k squared equals 1. Okay. And so what we have here is if the horizontal is the major axis, then sorry, the dogs, but we're gonna power through. Or maybe not. Hold on. Okay, let's hope this is better. Okay, so if the major axis is horizontal, then the A again, I mean, I guess this is maybe slightly different. Then the A goes with H. That's what you want to notice here. Horizontal, A is with X and H, right? So okay, maybe I should say that. Horizontal means A is with X. And then we have vertical. Oh, no, we want this. Vertical means A is with Y. Okay. But again, we basically have the same equation, but now we're calling it standard form for the equation of an ellipse that's centered at HK. So it's very similar to standard form, like standard form of a circle, just recall. And if you don't recall, this is it. Standard form of a circle is x minus h squared plus y minus k squared equals r squared. So for an ellipse, we have to let like well, it's not really the radius, right? But the right-hand side has to equal 1. And so in a circle, we let it equal r. It's whatever r is, and we create a circle from it. But in an ellipse, the right-hand side is always 1. And it doesn't really represent the radius, right? Because it may not be 1. So this is this is the formula, right, for this. And then these are what the graphs might look like. So if the major axis is horizontal, like it's not the x-axis, but it's a horizontal axis somewhere, so you can see that here, like this is the major axis, then it looks something like this picture, right? Now, it's not necessarily in the first quadrant. Like it could be, it could be that it's over here, or it could be crossing all of the axes here, so it doesn't have to be there, but they're just showing this example. And then the major axis for vertical is, and we don't say the y-axis, right? Because even though we have horizontal and vertical here, we don't say the y-axis because it's not actually the y-axis. It's maybe parallel with the y-axis, but because it's vertical, right? Okay. And so now we want to graph this ellipse. Okay. And then we'll identify the center, the foci, and the endpoints. Oh, it's even saying now the endpoints of the minor axis as well, which we did identify that last time. It just wasn't asked of us, I guess. So first we're going to kind of rewrite this. So this here, x plus 2, means x minus negative 2. So just keep that in mind, squared. And then y, and that represents like x minus h, right, squared. And this here is y minus k squared, right? So that tells us that h is negative 2, k is positive 5, okay? And let's see, 16 and 9. So this tells me that a is 4, and this tells me, oh, well, and I know it's a because it's bigger, right? So also major axis is horizontal. Because we still have, I don't think it was put up here, but we still have the case where a is bigger than b is bigger than 0. And so a is 4 and b is going to be 3. Now we can't just say, oh, okay, I'll graph 4, 0, and 3, 0. We have to first go to the center. So we start by saying the center is negative 2, 5, right? Because h comma k. Okay, this is so bad. And we start by graphing that. So I'm going to start by graphing negative 2, 2, 3, 5. So this is the center, right? Now from this center, I basically draw like a fake new x and y axes. So I'm going to do it in this light color here. And basically picture your x and y axis, and we just shifted them to negative 2, 5. And now that's kind of like 0, 0. Or you could kind of think of it this way, right? So now what I can do, since a is 4, from that point, I can go 1, 2, 3, 4 to the right because it's its major axis is horizontal. So that's a. And then 1, 2, 3, 4 to the left. And these are my vertices. So vertices are at, it doesn't even ask us to get these. Okay, never mind. I mean, well, we're getting them anyways because we're awesome. So negative 2, 3, 4, 5, 6. So it should be negative 6, 5 and 2, 5. So those are our vertices. Then our endpoints of the minor axis are, B was 3, so I can go 3 up from this and 3 down from this, right? And that would be -2, 2, and -2, what was it, 5, 6, 7, 8, right? And then I just have to get the foci, which I can do because we can calculate that. And I'll maybe connect this weird looking ellipse. Okay. Very circly, but not exactly. So now I'll calculate the foci same way I did before. So foci is c squared is a squared minus b squared. So 16 minus 9, which is 4. Oh, so this is gonna, oh no, it's not 4. Oh my God, I can't count. I wanted it to be 4, but it's 7. I was like, oh good, it'll be so nice, but no, it's not. But that's okay. So C is plus or minus the square root of 7. Now, oh shoot. Okay, C. All right. Here's where I'm a little bit off. I mean, not really, but it's plus or minus root 7. But in order to get there, we have to go from the center. So the foci points are actually at what we do if we take our major axis. So whichever one is major. So in this case, it's the horizontal, so it's the x coordinate, and we add or subtract our c value to, well, we add and subtract our c value to our x coordinate. So, and we're doing the same thing, but when it starts at 0, 0, you don't have to think about it. So here, I would say -2 plus square root of 7, comma 5, and then -2 minus square root of 7, comma 5. And these are from the center there, these are where the foci are going to be, right? So, I mean, square root of 7 is what, 2 point something. So you also could just go 2 point something distance away from the black point in the center. But the thing with that is you still have to get the foci points. Like, so you still have to write out what we did. So like 2 points. So it's maybe like here, and then, I don't know, here. And these are just approximate, right? So, so these are the foci. Right. And then we know the vertices and endpoints. And then this is where the link to that. So the first thing that I showed you earlier, and if you do want to pull it up, it's just Desmos, and you're just plugging in. So you can actually copy this link and go there, and you can change your values for H, K, A, and B, and it'll graph it for you. And it's pretty cool. You can kind of mess around with it. But I'll let you guys, or I won't. Well, we won't risk maybe losing internet or something. But it's what we were looking at before. And actually, you could probably take homework problems and plug in stuff there to see what they'll look like, or, verify or something like that. But it's also not too hard to graph, as you've seen. Now, here is where we get an equation that looks absolutely nothing like an ellipse. So this is maybe something I would call non-standard form. But it's more standard in that, like, we've seen stuff like this before, right? Like this is just some x squareds, some y squareds, and then numbers. This is just an equation, right? But we want to actually change it we want to basically kind of manipulate it, and we will complete the square, if you remember this. So this was another review that was done in the circles thing. So if you forget it, well, here we are, we're doing it now. And we'll complete the square, and then we will get in standard form, and we'll get our foci, our major axis, all of this, and we can graph just like we did before. So what I'm going to show you is first, our x's are going to stay together, our y's are going to stay together, and then our number is going to come to the other side, right? Because we want to get that one. We want that to be 1 eventually, right? So by doing that, I'm going to rewrite this whole thing. 9x squared plus 18x, and then plus 5y squared minus 30y equals -9. Okay, new equation, there it is, right? Now I'm going to start the process of completing the square. So first, I'm going to factor a 9 out of this, and I have x squared plus 2x. And then I'm going to say plus blank. This is part of completing the square, and we'll kind of finish that in a moment. Then I'll say plus 5 times y squared minus 6y, again, plus blank for completing the square. And then I'll say this equals -9, but then I'm going to have plus blank and plus blank, because whatever I do to one side, I have to do to the other side to make it even, okay? So, and normally when we complete the square, if we add 4, we also subtract 4, like we would add and then subtract because it was on the same side. If you remember, if you don't remember, don't worry about it. But now we're just gonna add whatever we add on both sides to make it even. I think my dogs have a shoe. Hold on. No shoe for them. Okay. So if you don't remember completing the square, I do recommend you kind of either look through the notes or watch a YouTube like example, like a video. Maybe it will help, because I will go through it, but I'm not going to like kind of, I guess, quote unquote, teach it maybe. But you take this term 2, you divide it by 2, then square it, right? So we get 2 divided by 2 is 1, 1 squared is 1, and that's the number you add here. Okay, same thing here. You take this number, divide by 2, then you square it. So 6 divided by 2 is 3, 3 squared is 9. So we add 9. Now the weird and tricky bit on the other side is because we took out this 9 and 5, we're actually not adding 1 and 9. Technically, we're adding 1 times 9. Like, so here, we're technically adding like 1 times or 9 times 1, right? So we're adding 9 to that side. And then we're adding 5 times 9. So 45. Because in the end, I would, if I like simplified this again, I would distribute that back in. But we want to complete the square and make it nice. So this is what we're doing. So from here, we rewrite the entire thing, and we'll say 9 times x plus 1 all squared, because that's what we completed the square. We made it nice. Plus 5 times y minus 3 all squared. And whatever, I will say, when you complete the square, whatever number you get when you divide by 2, that's the number that ends up on the inside here, right? I mean, it should work out that way, or it does work out that way, but you could also just factor. You could look at what you got here and factor it. It's x plus 1 squared. What you got here, it's y minus 3 squared, right? And then we have equals -9 plus 9 is nothing, and then plus 45 is 45. All right, now we're slowly cooking, right? So we want the right-hand side to equal 1. How did you, okay, so David asked, how did I get the 1 and the 5 again? Or the 1 and the, 1 and the 9, either way. So I get, let me try to, I get this value 1 by taking this number, divide it by 2, then square it. And I literally just drew a square, but squared, right? Same thing here. I take this number, divide by 2. I mean, technically it's -3. Then I square it. That's the number I add here. Yeah, 1 and 9. Yeah. And again, I recommend like looking either at the notes I posted or like at another example, like a YouTube video of just somebody completing the square. It should take you a few minutes and it'll like maybe help jog the memory too. Yeah, it's yeah, it is. It's confusing. So I do not blame you. Don't be sorry. Okay. So now remember, I want this to be an ellipse. So I want to divide everything by 45. Divide by 45. Okay. I didn't need to write this 3 times, but we're dividing everything by 45. So what we're going to get is on this side, 9 over 45 is 1 over 5. So it's x plus 1 squared divided by 5. Then I get 5 over 45 is 1 over 9, right? So y minus 3 squared over 9 equals 1. And now look at this. It took some work, but amazing. This is our ellipse equation, standard form equation. I guess the other equation is still an ellipse, but it's not standard form. So this is our standard form. And let's check out what we have. So I have a plus 1 and a minus 3 here. So remember, this was my h and my k, right? H, k. So my center is at -1, 3. Then I see 5 and 9. So the a is actually my 9, or well, a squared is 9. And 9 is bigger than 5. So that means my major axis is vertical. So this tells me major axis is vertical, right? And let's see, what else do we know? Oh, a equals 3. And b, okay, a little unfortunate, but b equals square root of 5, right? Unfortunate just because we have to write square root, but it's fine, totally fine. And then we can get our vertices and our foci. We can do all of this, right? So let's maybe first, or I'll calculate, before I graph anything, I'll calculate my foci. So it's c squared equals a squared minus b squared. This is where we get a nice thing because we get 4, right? So c is plus or minus 2. And so we need to take the center, which this center is -1, 3. And remember, because it's vertical, we're going to add the foci to the y. Okay. So we're going to get foci are -1, 3 plus 2 and -1, 3 minus 2. Well, and we can actually write that, but I wanted to show like what. So this and -1, 1. Okay, so those are our foci points. And so let's start graphing this guy, right? So the center is at -1, 3, -1, 1, 2, 3. So this is the center. And if I want to graph, well, my major is vertical. So if I go 3 up above that, 1, 2, 3, and 3 below, these are my major endpoints. And then if I go, square root of 5, okay, so this is where it's not going to get perfect because square root of 5 is, 2 point whatever. So if I just go 2 and a little, just estimate kind of, right? This is going to be where, so here is my ellipse, right? And my foci points, and maybe the center doesn't need to be maybe so big, maybe it's not, because it's like, it only helps you reframe, and I didn't draw the new axes, but it only helps you like reframe where are the axis points, right? And then so -1, 5 and -1, 1. This is nice because -1, 1, 2, 3, 5, and -1, 1. These are easy to draw as the foci points, right? So those worked out pretty nicely. And I think the only thing I didn't write, let's see, did I write everything? Identify the center, we did. The foci, we did. The vertices. Okay, so vertices, I do have to write that, right? That would be -1, 0. and -1. Let's see, what was that? 6, I think. Yeah. Okay, so so this is how we would do it when we're given some kind of like looking at this, looking at what we started with. We started with this kind of crazy equation that just I couldn't tell you anything much about it. But as we rewrote it in standard form, we were able to fairly easily find everything, right? So it's the rewriting that maybe is the most difficult part, just unless you don't remember how to find the center and the vertex, right? Like HK and all that. But now we look at a problem number 4 where it says, okay, we want to give the equation of an ellipse in standard form, and they just give us the center, focus point, vertex. So here's something a little different. They don't show us a graph, they don't do anything. I'm going to kind of sketch a graph of it to help us see like what the heck's going on here. But there is a way where if you just know the formula and you know what these are, like right, center is HK, the focus is going to be like distances away from the center, and the vertex is going to be also distances away from the center, right? So if you can kind of just if you use the formula to figure this out, that's also how we're going to do it. So let's take a look. HK is definitely the best information given. So we'd have x minus 1 squared plus y minus 3 squared. And we know it equals 1. The only thing we don't know is the a and the b. But so let's take a look. Look at the center. And then when you look at the vertex, like it gives you one vertex, but you can find the other based on that. But when you look at the vertex and you compare these, we note here the 3 and the 3. So y is the same. This means since the x changed, the x is the axis or is the major axis, so it's horizontal. So because of this, so I'll say x changes, so the major axis is horizontal. Okay, because we're moving horizontally here. And so we have x minus 1 squared over a squared, which we don't know yet, and then y minus 3 squared over b squared equals 1. Okay. So here we want to figure out what's a and what's b. That's like the first thing we're going to do, right? So we're going to figure out, we can figure out a by looking, so I'm going to graph, okay, let's see. I'm going to just graph some of these, right? So 1, 3 is my center. And then my vertex is at 5, 3. So 1, 2, 3, 4, 5, 3. So if this is a vertex and I see how many, it's 1, 2, 3, 4 units to the right from the center, then I know 1, 2, 3, 4 units from the right of the other center. This is the other vertex, right? So these are the vertices. And it's going to, it'll look something like, I don't know how big but it'll look something like this, right? So these are the vertices. And so that tells me that A is 4. So this is 16. Oh, that was weird. I think I just, okay. So that means that my equation goes to x minus 1 squared over 16. And then I got to figure out what b squared is, right? So to get b squared, I'm going to use the foci to get b. Because I don't know, like I just drew this, but I don't know what b is here, right? they didn't really tell me anything. They said the foci is at negative 2, 3. Okay, negative 2, 3. So the foci is here. So the other one would be, here. But so what? Like that's still right now in the graph, that doesn't tell us how high or low, like where B would be at, right? So, but we do know that C squared equals A squared minus B squared. And we know that based on this graph, and let me maybe count out. So here was my center, right? So center is green. And I went 1, 2, 3 to the left. So center 3 left of center is the foci point they gave. Okay, 3 to the right would be the other one. But so that means that C is 3. Right? So now I can say, okay, and that there actually might be other ways to calculate that if you wanted, like to actually use, like I'm using the graph, but you could use the points as well. And you could use the X coordinates and see how much they change, right? It's basically the change in X coordinates here because our major axis is horizontal. If it was vertical, it'd be change in Y coordinates, right? So C is 3. So I know that this would be 9. Oh, maybe I'll do 9 equals, and I know A squared is 16 minus B squared. And then we can just solve. So 9 minus 16 is negative 7, and it's negative B squared. Okay, so B squared equals positive 7, and then B is going to be square root of 7. Okay. So it actually doesn't matter that B is square root of 7 because in our formula, we just want B squared. So we can actually say, okay, this is 7, and here is my equation of the ellipse in standard form. Oh, wow. Okay, sorry about that. Okay, so hopefully we're all still together and you're with me here. The last bit of this section is going to be the eccentricity or eccentricity. I mean, I say eccentricity. I think you can say it however you want, right? But eccentricity of an ellipse, right? And this is, okay, here's that elongation. So there's the word, right? This is the degree of elongation of an ellipse measured by this, we call it little e. And what's a little bit confusing is this e is not the e exponential e. This is just e for eccentricity, right? Of ellipse. I don't know. We have lots of e's going on here. And there is a formula for it though. So we can get this formula, the e, right? We just do c divided by a. And again, a is the bigger of like A and B. A is the bigger one. And we would do C is from the foci, and we would do C over A. We know that C squared is A squared minus B squared. And also, you should always get E, that little e is between 0 and 1. Yes, thank you. Okay. Okay. Sorry, someone was just chatting, but we're good. So for number 5 here, if we want to determine this, well, we have 2 examples that they give us, right? The first one looks like this, the second one looks like this. We're going to see what these mean, and then we'll look at this application problem. So I will point out for right now, at least, that this, we would call this very eccentric or eccentric. Okay, I can't spell. And this one would be less or not as eccentric, right? And reason being, like, so it's based on how like thick or thin or fat or skinny or long or, whatever. And I think of maybe this type as more of a cheese puff, whereas this is like a pretzel rod or something. I don't know, right? Like, granted, maybe those are actually the same thing, but I think of a puff as puffier. So they're going to be, they look very different, right? One is very thin and long, and the other is just a little bit wider, right? Granted, this is not dependent on the major axis, right? Because I could have something that's very eccentric that looks like this, and I know the major axis is here, but I could also have something, like this, very eccentric, where the major axis is vertical, not horizontal. So in this case, vertical and horizontal do not matter. You should know 100%, you should know, but they don't change how eccentric or eccentric that this is, right? Okay, so I'm gonna just erase that. So let's figure out how to solve this. I first see this is the bigger number of 9. And so this is going to be my A, and it's the square root of that. So A is 15.
So can I just ask you a question? So does it depend on where from what I remember from the chapter, it seems like it depends on where the foci are.
Yes. So this and notice, so exactly what you said is correct. And reason being, look at this equation, right? So little e is strictly based on, it is based on A, which is on your major axis, not your minor, but it doesn't matter which is which. You just have to know which one it is. And it's also based on C, and C is strictly for the foci, right? Okay. Because we get like this formula here. This represents the distance from the center to the focus point.
Right.
And so our C is based on our foci, right? And since this little e is C divided by A, if our foci are are really large or really small, this is what's gonna make a difference. Yeah, so you're completely right. So we were able to get A and B, right? That's the first step. But now we don't have C, and our formula is C over A. So we just have to use C squared equals A squared minus B squared to solve. So C squared is 225 minus 9, which in this case is 216. And so C is the square root of 216, which we are going to simplify this. I know I didn't maybe earlier, but this one's kind of a big one. And it also equals 36 times 6. So this is 6 square root 6. Wow, maybe this is bad luck. Lots of 6s, but it's okay. If we lose internet, now we know it's like, I don't know, it's a bad sign. No. And so now we found C, and so we can calculate E is C over A. So it's going to be 6 root 6 over, what was A again? 15. We can reduce that to be, because 3 divides by 6 and 15, right? So we can get 2 root 6 over 5, because I just did this is 2, this is 5. If we divide by 3, okay. Those are my little scratch notes of how I did that, or what I did. And then you can also get this decimal, just because we do know the number should be between 0 and 1. So maybe it's good to check, right? And so let's see. So this one, it's about 0.98, or if you want it 9799 or something like that. So I'll just say 98. And notice how very close to 1. Very close to 1, right? And therefore very eccentric. This next example that they give here, we can see that the bigger number is 9. So this represents our A. So this means A is 3, B is 2. And C squared is 9 minus 4, so 5. So C is square root of 5, right? So therefore E is square root of 5 divided by what's A? Oh, 3. I keep losing myself. And this is about 0.75, I mean, or 7455 or something like this, right? Now, this is relatively close to 1, but not as close to 1. So notice, and therefore I say less eccentric, but notice the closer, well, okay, the closer to 0 you are, the less. It's basically telling you, like, it's on a scale of 0 1. 1 is completely eccentric, right? Or we could say, or has like the highest eccentricity, and 0 is none. So the less eccentric you are. I guess we'll just note that. But another thing to note actually is for a circle. So I'll kind of write this note here. A circle has eccentricity. Okay, I definitely can't spell that. A circle has eccentricity equal to 0. Okay, because if you look at an example like x squared plus y squared equals, I don't know, 25 or something. So that's a circle centered at the origin with radius 5. If we were to divide everything by 25, so if I divided by 25, and wrote it as an ellipse, I would get x squared over 25 plus y squared over 25 equals 1. And when this happens, A equals B. And so C is 0 because B squared minus A squared, or A squared minus B squared, is 0 if A and B are equal, right? So because of this, little e is 0 over A, which is just 0. Okay. So kind of bizarre, but hey, we'll take it, right? And you can think of it this way, that a circle is just not eccentric. And as you get away from that, whether you stretch, like as you stretch a circle or compress a circle up, right? You're getting more and more eccentric. And as you get to 1, you're almost flat, or you're like flattening a circle kind of, or getting close to a line. But it's a curve that's connected, so not a line, but yeah. Okay, so those are some good examples to see. Now, here's one application, maybe a motivation or something. And the whispering effect, it makes you feel weird. But so this application, so suppose a dome has a semi-elliptical ceiling. So actually, there's probably like so many places you could think of that maybe are like this. And they give us dimensions: 96 feet long, 23 feet high. So they said, okay, put 0 0 in the center. If it's 96 feet long, then 48 0 and negative 48 0. Those are those points, right? So they created this graph out of this dome with half of an ellipse, right? Semi-elliptical. So it's half of an ellipse. And part A says choose a coordinate system so that the center is 0 0. Okay, so they kind of already did this. And with the top of the ceiling is 0 23. So this is exactly what the picture is. So I actually don't, maybe I didn't mean to, I might have meant to take A out and include the picture. Otherwise, I meant to not include the picture and keep A there. So I'm not entirely sure, but let's see. Approximately how far from the center along the major axis should each person be standing to hear the whispering effect? That means, what is the foci? Because at the foci is where you should hear, where that effect should be the best. So let's figure that out. If we do this, we'd have our A is 48 and our B is 23, right? And so C squared is going to be 48 squared minus 23 squared. And I'm being a little bit lazy and not writing this out. But I also think I actually used different numbers here and did the wrong thing. So we're going to recalculate live in motion, in person here. Okay, so 48 squared minus 23. And you can check me as we go. So this, I'm getting 1,775. And let's see. Let's divide that by 25 maybe. Wonder if this can be divided by, just trying to see. Okay, so I think we can, this is, so C is going to be the square root of this, right? Which this is equal to 25 times 71 if we want to try to simplify, but I don't think, I mean, these numbers are crazy. We're going to end up having to get a decimal anyways. So we have our C value, and they're saying, where should these people be standing to hear each other if they're talking? Now, notice like all these weird arrows, like this bouncing here and here, or here and here. So the reason, what's going on is at the foci points, every one of these distances of their sound, of their talking, no matter what it is, they're all the same. Like the total distance is the same that it's traveling, which is why at the foci, that should be like the least, or the best sound, because no matter which direction they speak, the distance to the next person is the same, and it'll travel through. Granted, okay, if you're super close, you could just hear each other from being close. But say this was, I mean, if it was like you were in the room, and if it's really, I don't know how, 48 feet, okay, maybe it's not far enough away, but maybe double it or something, right? Or if, I guess technically, okay, we're whispering, I forgot. So if you're whispering and you're so close or far, maybe you can't hear each other. But if they whisper in the direction of the dome, the distance from the two foci should just be the same, right? So this is pretty cool. So, well, let me get that decimal also, because I'm realizing like we should figure out what this is, right? It's about like 42, but 42.1. So kind of about 42. So approximately how far from the center should each person be standing? I mean, oh, and it says round to one decimal. So I got like 42.1. I don't think that rounds up. So yeah, Paul, it's pretty cool, right? If you ever experience this or are in a dome or something, like you can whisper. It makes me think of those microphone, or those like, oh my God, what is it called? But like the games, I feel like my sister and I would do it, where you'd like talk through a paper cup attached to a string and like talk into it, and they'd hear you, in another room or something. I don't know. It makes me think of that, even though it's not the same thing. But yeah. So we would say approximately 42.1 feet from the center is where both of these people is where they should stand. To have this whispering effect. Because otherwise, if you're not exactly in that place and you're too close or too far, when you're whispering, you may not hear each other. But also, if you whisper up, the distance might not be, like the distance might be too far, too close, not working out where this effect is happening. But or you would have to whisper in a specific direction in order for the person to bounce off and to hear you. But if you're at this foci point, literally any direction you speak, it travels the same distance, and you guys should be able to hear each other. And in practice, I don't know that I've ever tried it. I feel like I've been in a dome before, and you hear, or like even, okay, this is a weird example, but even if you're like out on a boat or something, right? If you've ever been on a boat or kayaking or something, and you can like hear, like sometimes there's a moment where you can hear like a conversation kind of quietly that's happening, I mean, really far, like across the water, or, but it's because it's traveling on, I mean, this is not the same thing as, or maybe it sort of is, I don't really know, but this is like the sound is traveling on the water, right? Or like you can hear it, and it's very kind of bizarre. So it makes me think of that as well. But I haven't been in a dome lately, I guess, unless you count like a room in my house with no furniture. It echoes real well in there. But
I think that's just reverb. But
yeah, I was gonna say, but I don't think that's this problem, right? Because I don't think that works. That's not the whispering effect because we're not in a dome, right? Well, my house is not shaped like a dome, so
mhm.
I don't know if that's fortunate or unfortunate. Probably
I
fortunate.
went to this place in India a few years ago that had like some interesting acoustic properties or whatever. And but I don't know. I've seen something like this before, but I can't remember where it was. But I definitely remember like in this fort, you could be real high up and you could clap, and the person like at the gate could hear you.
Yeah,
and,
like that's really
It
cool.
was
And
to alert, you know, of invaders or something like that.
Well, Jakob says almost all mosques have that too, and that's super cool. Yeah. And this, but okay, how crazy that, you know, they probably discovered this a long time ago when it was being built or whatever, right? And really, this all comes down to some math, guys. You know, it's all that good old pre-calculus. You know, even in whatever times, this is what they were doing. Okay, so we did finish this a little early today, but maybe that's okay. I can stick around. My question today, we're going to do some Thanksgiving questions today and next week. So today, I was going to say your favorite Thanksgiving side. Let's start with a side and maybe hold off on dessert because maybe that'll be a separate question, or it'll be something else. But let's do Thanksgiving side. That'll be the question of the day. And I will stick around for a little bit, but let me like save these notes and maybe get some things in order here.
Well, one of the interesting, going back to number 5.
Yeah.
One of the interesting things about that eccentricity is that, you know, the foci, the closer they are to the center, the more like a circle it is.
Yeah. So because a circle, because a circle is like, or you could either think of it as not at all eccentric or perfectly eccentric, right? But yeah, it is very strange that a circle has the eccentricity of 0, right? But
as the foci move out, then
it's
like maybe there's a way to see that on that Desmos thing. Like you could,
I would definitely say so. So if you mess around with that, and you know, you could probably look at that for a while too. Just kind of, it's cool. Or even like there's videos that, you know, that are, or like those, you know, well, I want to say when we were kids, but this is probably not true. Oh yeah. So Joseph, class is totally done. Sorry, I'm not reading all the chat, but type in your favorite Thanksgiving side. I'm going to just get out of this and I'll post the notes tonight. But on Tuesday, we are meeting and it probably will take the whole time because we have to get through 2 sections. So I could have, if I was prepared, I could have done a little tonight, but we'll definitely do it. We'll finish in time. It'll be fine. But we're going to do 11:2 and 11:3 next on Tuesday. And then, I was going to have a quiz, but I actually never wrote it. And so I am too busy. So I'm very sorry. If you want like extra questions, I can provide more review and book questions. But maybe I'm being too honest with you all that I'm just way too busy to write a quiz. So thank you guys. Yeah, I know. I was kind of surprised that tonight ended early as well, I guess, but that's okay. It's kind of nice, right? To get a little break once in a while. But it reminded me, you know, those, with like the things you can look through and turn it. And it's like crystals or like weird designs and patterns. If anybody knows what I'm talking about, you know, it's like a kaleidoscope. Yeah. Is that, Oh my God. So there's a name